Hello friends, welcome to Daring Marina YouTube channel. Today we will be discussing about the governor and control topics continuation. Electronic digital governor for bridge control. Okay, so bridge control using an electronic digital governor. This consists of 4 units, namely digital governor, remote control unit on bridge, engine telegraph and engine protection device. So here first digital governor. Here we can see from the bridge there goes to RPM command, then there goes to regulator gain, then to a fuel limiters, then actuator command, then actuator positioner, actuator, then so the governor will actuate the propeller. Then after that for the propeller we will check the measured RPM. So the various commands that are described below are RPM command. It is the order from bridge requesting a certain speed. This input signal should meet the safety settings. That means the RPM should not rise too fast, causing the engine to overload, or RPM should be within the critical speed range. Then measured command. It is the RPM measured at engine by means of 2 inductance pickup fitted at the toothed ring. The higher RPM value is chosen from 2 pickups. Then RPM comparator. It compares the measured RPM with RPM command decided by bridge and sends a resultant signal to the regulated amplifier. Regulator gain. This indicates gain or sensitivity of governor during different engine load condition. Example, with constant fuel setting, the deadband of controller output is increased, so that engine speed change of at least 2 RPM is needed before the governor responds. With rough sea setting, the governor output varies with engine speed changes. Then controller pain. This is a P&I controller. The P gain is varied between normal and rough sea options. Rough sea has slightly lower gain since the deadband of controller output is reduced. I gain increases in rough sea condition, which slows down the controller response. The gain also improves with both P&I function. Difference between the desired and measured RPM value increases to improve controller response and prevent overspeed of engine. Fuel limiter. There are 3 fuel limiters, that is maximum fuel limiter. It is used to avoid mechanical overloading of engine, that means excess firing pressure and excess bearing loads. It can be overridden by bridge using cancel limiter button, but the engine should never be run more than 110% load for more than an hour in 12-hour period. Okay. Then torque fuel limiter. It is used to limit the fuel to avoid excessive torque condition, that means high thermal load on engine and high torsional loads on crankshaft, especially at low loads. Scavenge air limiter. It is used to limit the fuel as per scavenge air pressure available to ensure proper combustion. Actuator positioner. The actuator gets an input of desired fuel command signal. It compares it with actual position of actuator and sends a resultant signal to actuator, which is amplified before being fed into the actuator motor. Actuator speed pickup. It is a feedback link which prevents excessive actuator motor speed. It allows actuator amplifier to position the actuator at the correct position quickly. Actuator. It is a brushless servo motor fitted with digital encoder for motor output position. Remote control unit. Here we can say bridge from the remote control unit. The mimic diagram as shown displays the function of remote control unit from the bridge. This diagram has indicator lights to show the sequence and changes taking place during maneuvering. The following components in mimic diagrams we can discuss. So the bridge shows bridge control. Okay. After that, system simulation. This is used during testing and simulation of engine running condition while engine is actually stopped. Stop indicates that bridge telegraph lever is at stop or the emergency stop button is pressed. Ahead or ascend command. It only indicates the bridge command that has been requested, not the engine or camshaft position. Start block. It indicates that Engine starting is blocked in case of turning gear is engaged. Low start air pressure, both RPM deflector flame, engine tripped, automatic starter valve blocked or starter distributor blocked. Above reversing limit, this indicates engine speed is more than maximum level at which brake air can be supplied. Start set point, this indicates governor setting is at preset start level to allow sufficient fuel for starting. This signal is maintained for 6 seconds. Ahead or astern, this indicates presence of bridge speed or setting signal. Stop governor, this indicates presence of a signal to governor to stop fuel admission. This is not a cutout device. Cancel limiter governor, this indicates scavenge air limiter and torque limiter are cancelled. This happens in case engine fails to start after 3 automatic start. An alarm indicates the repeated start function activation. About start level indicates the start system will be activated to brake the engine before reversing can take place. Start SV indicates start air system is activated. Stop SV indicates starting air has started the engine above the set point for starting. Set point limiter indicates that the bridge engine speed request has not been allowed due to load up program being activated above full head ahead RPM or due to critical range speed being blocked by bridge control system or slowdown condition has been activated. This can be cancelled at the bridge panel. The third one is engine telegraph system. It conveys the speed and direction command from the bridge to the engine control room personnel. When on bridge control, engine room telegraph control is disconnected and becomes transmitter or receiver for bridge to engine room command communication. It indicates standard ring of bell if the bridge and engine telegraph position do not match. A wrong way alarm indicates engine room telegraph and engine room rotation are opposite. Then failure of remote system power supply indicates bridge control is no more possible. So emergency control may have to be done in case of failure of engine room in case of failure from engine room control. And internal communication failure between telegraph and panel. Indicators of finish with engine, standby and at C modes. So engine protection. So for engine protection, this is provided to safeguard engine during overspeed, that is 107% of the maximum continuous rating. It activates emergency stop solenoid for shutdown of the engine. Shutdown for low lube oil pressure at 1 bar, jacket water high temperature at 96 degrees Celsius, thrust block high temperature 85 degrees Celsius, camshaft low pressure at 1.5 bar. Slow down to dead slow RPM due to low lube oil pressure, that is 1.5 bar, low camshaft oil pressure, that is 2 bar, thrust block high temperature, that is 75 degrees Celsius, piston coolant no flow, scavenger temperature high, oil mist detection high, cylinder exhaust temperature high, lube oil inlet temperature high, piston coolant high temperature. These are the conditions where we need to slow down to dead slow RPM. So emergency run button of the bridge can override the shutdown function. So these are the some brief about the govern run control. For the next topic and all we will be discussing more. Thank you.